Hello friends, let us move to our today's first question, which is we have to find shear force and moment or bending moment of a given simply supported beam. We have one point load here. One point load is given 70 kilonewton at a distance of from left hand side 4 meter and right hand side 3 meter, and the span of this beam is 7 meter. Total beam length is 7 meter. In this, we have to find shear force and bending moment or moment. Let us make it very easy. First of all, we'll try to give the names here. We'll give the names. Let us, this is as A, this is B, and this one as C. When this load is acting as a point load on this beam, so first of all, we need to find the reaction on this reaction at support A and reaction at support B. So we have to find RA and RB. The first step, taking moment about A. Taking moment about A. It means I will multiply this RB times the whole length. RB times this whole length, the 7 meter. I will write RB times 7 equals to 70 times 4. 70 times 4 means this distance. Let us simplify this. It will be 7 RB equals to, this will be 280, and if you simplify more further, RB equals to 280 by 7, it will be 40. Since the unit is kilonewton, so it will be kilonewton. If we have got RB, then it's very easy to find RA. How? RA plus RB equals to the total load 70. In this, we have got the value of RB, which is this. We will substitute here. RA plus RB means 40 equals to 70. If we simplify this, 40 goes to this side means minus 40. It will be 30 kilonewton. We have got reactions. RA means 30 and RB means we have got 40 kilonewton. So first thing we have done reactions. Next is shear force. I will write here shear force. How to find shear force? If we start with B, shear force we will consider like shear force at, let's say start from right hand side. Shear force, it means force at B, FB we can write, equals to, what is the reaction here? 40. So we write 40, but here, right, since it is right hand side and acting towards up, so it will be minus 40. In few books, it is given negative for the right hand upward forces, and in few books it is given negative for the downward forces. But here we will use negative for the upward forces. So this is as minus 40. This is shear force at B. In the next step, we will find the shear force at C. Shear force at C equals to, we have minus 40, then 70 downwards, minus 7 plus 70, it means it will be 30, which is positive. Then shear force at A. What is the reaction here? 30, which is 30. In the next step, we will find moment. Moment at A, B and C. For moment, it is denoted by, let's say, M. Moment at A equals to moment at B equals to, if it is simply supported, it will means 0. There will be no moment. The only thing left here is moment at C. Moment at C equals to, we have two methods. Either we can, or either we can multiply this RB times this distance or RA times this distance. What we can do, let us take RB 40 times, which is what? RB. I will write here for your reference. RB times 3. RB times 3. So RB means 40, and here the distance up to C is what? 3 meter. So moment at C, 40 times 3, 120 kilonewton, or 30 times 4, it will be 120 kilonewton. So we have got moment at C. Now the next step, we will draw the diagram of shear force and bending moment, which is based on these results. How? Up to 4 meter, we will draw here. Let's say this distance is 4 meter, and from here we have, like, this force is minus 40, then next is 30, one reaction positive, one reaction is negative. This will give negative and this will give positive, and this part will be 40 kilonewton and this part 30 kilonewton. Okay friends, now if we talk about the moment diagram, if you extend these lines, this is the basic line, this is the total distance. We have got the distance from right hand side 3 meter, from here 3 meter, and what is the moment? 120. From scale you can consider 120. Then you can close this moment diagram. This from here and this is here. This is positive moment which we have here.